My name is Hartmut Quast. I'm with WHO Engineering. We are a company that has been around for more than 20 years, and we have started with LonWorks development at that time ago. And actually, my personal background started with LonWorks already started at the same time in the 90s. And I'm actually with WHO for more than 10 years, and my personal role is head of software development within WHO. Well, we want to present a new communications channel for wireless communication via LonTalk, and I'd like to go back a little what we had in the past, in the 1990s and in the 2000s. We already had the decentralized automation with the interoperable devices and a structured network. We had devices for everyday applications. We had devices for building automation, for industrial automation. We were able to communicate small packets in a peer-to-peer fashion. We had timely responses for those packets. We had security already integrated into this, and also LonTalk has ever been or has always been a reliable protocol. LonTalk has all the time implemented all the 7 layers of the ISO OC model, and so it was very easy to adopt to different communications media. In the past, when you take a look at the picture, we had the ability to communicate over twisted pair lines. We had the ability to communicate over narrow band power line, but we also had the ability to connect to the internet via IP routers and connect our systems to centralized management systems over the internet. They were accessible over the internet. And so now our mission was, as the requirements were a little were broadened, to have a radio communications channel for LonTalk. And we took a look at what the requirements for the wireless communications channel actually are, and we very fast came to the idea to use a meshed technology, because if you just have a single point where you have your network access to, it would mean that you would have to connect to every device from that one point, and you have to have a direct connection, direct radio connection to that device. And if you use a meshed network technology, of course, you will be able to have a broader scale and have more possibilities to connect to devices which are not in the direct range of your central point. And of course, we need to have a reliable link. We need to have a robust network. The network needs to be scalable. We want to have a few devices, but we want to be able to support a couple hundred, maybe a couple thousand devices within a LonWorks RF channel. Of course, within LonMark, because this is a LonMark channel, we need interoperability. We need the self-organization of the network, which helps the robustness. We need to have the end-to-end reliability. And of course, with wireless technology, you always need to have some sort of means for security. You don't want to have somebody interfere with your network just by connecting with some sort of RF device which you don't know anything about. We would like to have mobility support, so if the devices move, we will still like to be able to access those devices. And of course, we need some sort of low latency in order to support the timing requirements that the protocol has. And we evaluated a couple of systems, but actually we decided for a system from a company called WirePass, which is based in Finland, and they are offering a protocol stack for a wireless technology, for RF, which sort of fulfills all the requirements that I was just talking about. They are actually having a mesh net technology, and that actually means that every device that we have in the network can act as a router. The scalability is fulfilled. They are able to support up to 16 million devices. They have a 24-bit address space, and of course they can use quite a few devices, ranging from 1-2 devices, but you can go up to a couple of million devices. The largest installation that I'm aware of has about 700,000 devices, actually. Okay, as I said, every device can route, so we're able to use different paths for accessing a single data point in the network. We have adaptive routing, so if there's some obstacle on the path that the routing changes and the packets may take a different path. That's all being done and handled by the stack dynamically. They have adaptive transmission power control, so they don't have to use the full power for sending. But if the stack recognizes that there's problems with the transmissions, then the stack can actually send out the messages with more transmission power. And then we can operate on different frequencies within the frequency band that we're using. And also the stack is able to recognize that there's channels which are occupied maybe by some other radio applications, and the stack just uses then different channels in order to get the messages or to get the data through the radio channel. And of course, for reliability, one important characteristic is, or feature is, the acknowledged service. They actually have an acknowledged service on a peer-to-peer basis. So the WirePass stack is able to send the messages from one device to another device and have the message acknowledged. As I said, we need to have security. We have the WirePass stack implements the advanced encryption standard with a 128-bit key, and it uses a one message authentication key for message integrity. It can operate on different hardware. It says any hardware here. Actually, we are at the EasyR32 microcontroller family, and there's different types of that controller, and which can be used to adopt to different frequencies. Currently, we are able to support the 868 channel for Europe, for the 915 megahertz channel for the Americas, and 2.4 gigahertz is also on the roadmap, but we're still evaluating this. Actually, it is already supported by WirePass, and they're doing applications with this. One interesting feature is you can use this on closed or public networks. So you don't need to rely on any other provider like telecom, or you don't need to have 5G or LTE. You can set up your own network. You can have your own infrastructure and operate that infrastructure. You need to, of course, comply with the regulations that you have, but you're independent from any provider. And there's no recurrent fees on that. Of course, there's a fee for the stack, but this is actually included in the implementation, as we'll see later. Yes, and for the medium access, it has synchronized multi-channel access, and we're using time division multiple access as well as frequency division multiple access, as I sort of explained before. So from what we've learned so far, the approach of the technologies is similar. We have the multi-master system in LonTalk, as we have traditionally known it, and of course, the features that WirePass offers are very similar to this. So we also have a decentralized multi-master network. We don't need to have any master to operate this network. It can operate independently. And as in LonWorks, we can have direct access to single data points on any device that we have in the network. And regarding the addressing mechanisms that are present, of course, they support a broadcast addressing mechanism, they support multicast, and they support unicast. So that's all of these addressing mechanisms that we need for adopting this system as a LonTalk communications channel. Well, a couple more advantages for the combination of using WirePass and LON. Of course, the Neuron is able to handle the communication speed of the WirePass network. As I explained before, we can do an easy address mapping of the WirePass addressing scheme to the LonTalk addressing scheme. When we start setting up a WirePass network, you can actually do this from scratch. You can take the WirePass devices which have been pre-configured with a key, with a network identification, and there's no need to do additional steps for the system integrator. So the system integrator can start with the tools he already knows, for example, the OpenLNS commissioning tool, but he can of course use any other